Hi, and welcome to part 4 of this Python 3 deep dive series. My name is Fred Baptiste and I'll be your instructor for this course. So what is this course about? Well, just some course philosophy. This course is about the Python language and the standard library, and in particular, of course, I'm referring to the canonical CPython implementation, and I'll be using and expecting version 3.6 or above. This is about becoming an expert Python developer and learning idiomatic Python. It's about obtaining a deeper understanding of the Python language, as well as the standard library. So this is not an introductory course. There are some prerequisites, and I really strongly suggest that you take a look at the prerequisites video in order to make sure that you have what it needs to really get the most benefit out of this course. Because this course is not a cookbook course. I expect that students taking this course have already done some practical Python programming. They already know how to solve problems. They already know what problems they're working with and what they want to do. This is not a course that's going to teach you how to program in general and how to, solve a specific problem. These are your problems. I can't cover everybody's problems. So you are going to come into this course knowing already what you want to learn and what you don't know and where you want to get more focused in order to benefit your professional development career. So here are the course topics that we're going to cover. We're going to focus on object-oriented programming concepts that are, of course, in Python. So we're going to look at classes or types and objects. We're going to look at how we can create instances of classes, instances of types, and we're going to look at that cycle of what happens when we do a creation and initialization of classes and objects. We'll look at functions and methods and properties and attributes, and we'll separate these data attributes versus these callable attributes because there's a big difference in how they get handled when we're working with classes. So we'll take a look at that in some detail. We'll take a look at polymorphism, and we'll see how the special dunder methods are basically what Python gives us to provide implementations for the standard operators. So for example, we can now define what addition means between two instances of our custom classes. And that we do using the special dunder methods. And this is how we have polymorphism in Python. So we'll take a look at that in some detail. You've probably already seen those things before. Then we'll take a look and focus on single inheritance. Python supports multiple inheritance, but first we really need to focus on single inheritance and understand that properly. A lot of the work that we can do in Python object-oriented programming doesn't require multiple inheritance. In fact, many languages like Java, for example, don't even support multiple inheritance. Then we're going to look at descriptors. Descriptors are fundamental to how object-oriented programming works in Python. They're fundamental to things like properties and methods. And although we can get by without understanding data descriptors, and then we can just use the properties and use the methods and just think, okay, well, something magical happens and it just works, that's great, but it doesn't really provide us any insight into how things work, and we really need a better understanding of that. So data and non-data descriptors are fundamental to that. So we're going to spend a relatively fair amount of time on this complicated topic. Then we'll take a look at enumerations. Enumerations are a very handy way to deal with collections of related constants. Of course, we can use, module level global attributes basically, and we can create lists of these global attributes in the global scope. That's great, that works fine, but enumerations provide us a lot of extra functionality that makes it really nice to work with. So we'll take a look at those and see how we can extend them and use them to solve our own problems. Then we'll look at exceptions. Exceptions and exception handling is fundamental to any kind of programming language, and Python, of course, is no exception. So we're going to look at exceptions, and you should already have some knowledge of that. You should already know how to raise an exception and how to catch them using a try block and with accept statements. But we'll take a look at that in a lot more detail. We'll take a look at how we raise exceptions, how we handle exceptions, and then we'll take a look at how we create our own custom exceptions and our own custom hierarchy of exceptions, and how we can extend the functionality in order to provide things that may be more applicable to the particular problems that we're working on. In terms of the included course materials, every topic has 2 sections. It has a lecture video and a coding video. So lecture is more theoretical, it's just explaining things, and in the coding we actually get into the nitty-gritty details and actually see how things work using code. And for a lot of the stuff, I use Jupyter Notebooks because I can fully annotate all that code. So all those notebooks are available for download, and they're fully annotated as well. So it's not just the code, but it's also explanations about the code that you can download. I have PDFs for all the lecture slides, so if you want to read them offline, you can. And then there's, of course, projects and exercises and solutions with videos for each of those as well after each main section. And then all the code is also in a GitHub repository. So I suggest that you grab the code from there. It's always going to be the latest and greatest, and you need to start getting used to using Git anyways, so might as well. And this is the location of the repository where you can get all the code for this course and also all the other deep dive courses as well. All right, so thanks for watching, and I hope you'll join me in this object-oriented programming deep dive.